Okay, we're looking at question number 34 that's on page 20 in your Unit 2 packet. This is about gases and gas laws. So I read the question, and the first thing I can see is it's not a factor label question, so it looks like a word problem. So I am going to jump into my problem solving process here. And so I'll set up my T-chart. And let's think about what information we know. Okay, it tells me I have a container. In that container, there is some nitrogen gas, there's some oxygen gas, and there's some hydrogen gas. And it tells me that the total pressure of that container is 465 kilopascals. So we'll set that up in our data table. Now it tells me in that container there is some nitrogen. I don't know how much nitrogen there is, but I know that there's twice as much oxygen as nitrogen and 3 times as much hydrogen. Now the question is asking me what is the pressure of the oxygen? That's what it wants to know. And at this point, I don't know what the pressure of the oxygen is, but it gives me some information about my oxygen molecules compared to my nitrogen and hydrogen. Now, the problem does not tell me how much nitrogen I have, nor do I know what the pressure of the nitrogen is, so that's a big question mark. However, it does go on to tell me there are twice as many particles of oxygen as nitrogen. Now, since they're in the same container, the volume that the oxygen is occupying is the same. The temperature must be the same. But since there's twice as many particles of oxygen as nitrogen, that means the oxygen must be exerting twice as much pressure as the nitrogen that's in there. So because of Avogadro's law, double the number of particles, you will double the pressure, I can make that statement. So while I don't know what the pressure of the oxygen actually is, I don't know the number, I know that the pressure of the oxygen is going to be 2 times whatever the pressure of the nitrogen is. So I can do that little trick in there and show how those two relate, even though I don't know an exact number. And we can do a very similar trick for the pressure of the hydrogen. Again, it doesn't tell me how much hydrogen I have in there, nor does it tell me the pressure of the hydrogen, but it tells me I have 3 times as much hydrogen as nitrogen. So since there's 3 times as many hydrogen molecules as nitrogen, that means the pressure of my hydrogen is going to be 3 times the pressure of the nitrogen. So this is a little trick we can do sometimes when we don't have actual numbers. We still can draw some relationships in there, and this is going to be really the trick to turn this into a pretty easy problem from this point on. So now that I have my data table done, the next thing I want to think about is, well, what formula can I use to answer this question? Well, I even see the word partial pressure, so that kind of clues me in that this is a Dalton's law of partial pressure problem. So Dalton's law of partial pressure says that the total pressure in the container is the sum of the individual pressure from each gas that is in that container. So it's generically written as PT equals P1 plus P2 plus P3. But instead of using ones and twos, let's make that specific here. In this case, we've got nitrogen that's in the container, we've got oxygen that's in the container, and we've got hydrogen that's in the container. In fact, I've got 4 variables in my problem. When I look at my data table, well, I don't have numbers, but I do have information about all of those. So in fact, we can actually go ahead and resubstitute some of these guys in. I know what the total pressure is. I know that that is 465 kilopascals, so I can plug that value in. Okay, and that equals my pressure of the nitrogen. I do not know what that is, so I'm just going to keep that P to the N2. Now pressure of the oxygen, again, I don't know what that is, but I know that it's twice the nitrogen, so I can substitute this in. Instead of writing PO2, we can plug in that the PO2 is equal to 2 times P of the N2. And then we can do the same thing for pressure of the hydrogen. Well, I don't know what the pressure of the hydrogen is, but I know it is 3 times, so we'll just substitute my 3 times the pressure of the hydrogen. Sorry, I'm running off the board a little bit here. So that means I can actually simplify this side. Rewriting it, I get my 465 kilopascals is equal to, well, P of N2 plus 2 times P of N2 plus 3 times P of N2, and this is an N2 on the end here. Well, I can add those all up together, and that equals 6 P of the N2. So now I can actually solve for P of the N2 by simply dividing both sides by 6. If I divide both sides by 6, my 6's cancel out. So I take my 465 kilopascals divided by 6. I come up with 77.5 kilopascals. Now I want to label that. That is the pressure of the N2. Now I haven't quite answered the question yet because the question is not asking me what the pressure of the N2 is. The question is asking me what the pressure of the oxygen is. Well, as I have over here in my statement, I know that the pressure of the oxygen is twice the pressure of the nitrogen. So I just have to take my 77.5 times 2, and then I know that the final answer to the question, and I don't have time to really show all my work for that, but my final answer to the question then is that the pressure of the oxygen is 155 kilopascals as the answer to that question.